1.
All right, I'm going to show you guys how to make a basic scatter plot graph, which I often just call a line graph, probably incorrectly. So you always start, this would be your independent variable, and this is your dependent variable. And you'll remember your independent variable, it always goes on the x-axis. So we'll say missing science assignments down here. And then you're going to label that if it has units to measure, but in this case it does not, so you don't need units there. And then let's do the same for the dependent variable right here, average grade in science class. And I'm just going to call it average grade on this side. Let's put a title on there because that tends to be the thing people forget the most, and you usually want to include your two variables. So you want to include your independent variable and your dependent variable. So in this case, it's going to be missing assignments versus average grade. Okay, and then we need a scale for each axis. So let's take a look at the x-axis first. You should always start at 0, so it doesn't really matter for each axis, so I'll just put zeros on each. And then let's deal with the x-axis. So usually what I do is I just look through and find the biggest number in my data, and it happens to be an 8. And the rule is that the 8 has to appear somewhere on the second half of the graph when we come up with a scale. So let's see if we can come up with a way to do that. So if I counted by tens, for example, and I make this 10, well, now my 8 would be right here, and my entire graph is only going to take up this little bit of space. So that's a bad scale. So what kind of scale can we come up with? Counting by ones may do the trick, so let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my 8 is indeed more than halfway across my graph, so I'm good to go. All right, and let's do the same on the y-axis. So here's my y values. And it looks to me that the biggest number is 97, and we need to graph that. So again, we need to come up with a scale. It does not have to be the same scale that you would have over here on your x-axis. It can be a different scale. So let's see what we can come up with. If I counted by fives, for example, I had to go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and I won't make it to 97. So let's spread the scale out and try tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and that works perfect. My 97 will be somewhere around there. One mistake some students will make is they'll just look at all these numbers and they'll put those numbers on the scale itself, and that you cannot do. You have to have an even interval scale. So that means that I have 10 between each number in this case, or in the x-axis, 1 between each number. Okay. All right, now it's relatively simple. We just plot it. These are our x values, comma, y values. So this looks just like math class now. So I have 0 and 97, and I'm going to put a dot there. Make your dots so you can see them, big enough to see on your paper. 1 and 93, and you put a dot. 2 and 85. 3 and 81. 4 and 73. 5 and 63. 6 and 45. Struggling to find it. I think I got it. 7 and 39. And finally, 8 and 20. Okay, so possibly in elementary school, you were taught to connect the dots like that. You are not going to do that in middle school science. So what we usually do is we call this a line of best fit, or I usually just call it a best fit line. And what you're trying to do is you're looking at your data and you're trying to decide what kind of mathematical line best fits this data. Would it be a straight line? Would it be a, don't write this yet, a curved line? Would it possibly be a straight line this way? So you need to figure out what kind of line you're going to draw. So in this case, you could try a straight line on there. So let's just try it and I'll see what it looks like. And you want to average your errors. I might have that line a little high, but to me, it looks like maybe it's better represented by a curved line. I have data points all above and all below here. So I would probably choose to draw a curved line on that. And I'll try to do that right now with you. So I'm going to come through here something like this. You don't have to hit each dot. It's better that it's smooth. So you see I kind of went in between those. A smooth line that could be represented with a math formula. You might ask, why in the world do we do this? It's because in science, there's always errors. And what we're trying to say with our best fit line is if there was no error, we actually believe that data point should be on the line. And that data point should be on the line. And that data point should be exactly on the line. So we're trying to average any errors that we have and make our line look like something you would graph in a math class. I hope that helps for a tutorial.